In this video, we will find the radius of convergence for the power series, these two. Many students use the wrong method to find the radius of convergence of this type, but the answer turns out correct sometimes. But this will not be the case every time. Okay, so to get the correct answer every time, you have to follow the correct approach. So let's start this. Here, okay, notice here what you write. An is equal to n to the power n factorial over n to the power n, isn't it? But this is incorrect. You don't write it. Why? Because if you equate this series with this one, an x to the power n, see the suffix of a is same as the power of x, but here the power of x is 2n. Right, so this is the coefficient a2n, not an. So we will write ak is equal to n factorial over n to the power n when k is 2n, for n is equal to 0, 1, 2 up to infinity and 0 otherwise. This is very much important. Okay. And why this step is so important? Let's find out in the next step. Okay. We will find ak mod whole to the power 1 over k. Okay. Here we are using k is equal to 2n. Why? Because otherwise it is 0 and we have to find the limit superior. Right. So mod ak becomes n factorial over n to the power n and k is equal to 2n, not only n. Okay. So we will write k is equal to 2n right here. Now we will write this as n factorial over n to the power n whole over 1 over n over 1 over 2. Okay. Now we will use some result. This result says if un is positive for every n, then limit un plus 1 over un is L, where L is finite or infinite, then un whole over 1 to the power n is equal to L. Okay, so to find this limit, we will use this result. Now let us find limit if we denote this as Vn, n factorial over n to the power n, then let us find limit Vn plus 1 over Vn. Okay. N tends to infinity, which is n plus 1 factorial over n plus 1 whole to the power n plus 1 into n to the power n over n factorial equals to limit n tends to infinity. This one n plus 1 gets cancelled with this one. Okay, so it will become n factorial over n plus 1 whole to the power n multiplied with n to the power n over n factorial. So we cancel these two and what remains is limit n tends to infinity 1 over 1 plus 1 over n whole to the power n, and this goes to e. This one goes to e, so this whole limit goes to 1 over e, right? So using the result, we get what? Limit Vn whole to the power 1 over n equals to 1 over e, right? And since k is equal to 2n, see right here, k is equal to 2n, so as k tends to infinity, n tends to infinity. So we will find limit k tends to infinity mod ak whole over 1 over k is equal to what? 1 over e whole to the power 1 by 2. Don't forget the half right here. Okay. So the answer is 1 over e, 1 over root e. But this is not the radius of convergence. Why? Because the radius of convergence is 1. If the radius of convergence is r, then 1 by r is equal to 1 over root e. So r is equal to root e. So this is our required answer. So here we are done, and don't forget the most important thing, that here we are finding limit superior of mod ak whole to the power 1 over k, which is equal to the limit of the subsequence vn whole to the power 1 over n. That means vn is a subsequence of ak, right? Now for the next series, this one, see, this is sum of two different power series, right? Now let us write these two distinct series as an plus bn x to the power n, where an is equal to 1 plus minus 1 whole to the n over 2 to the n, and bn is equal to 1 plus minus 1 whole to the n minus 1 over 3 to the n. Now what we have to do is to find the radii of convergence for these two different power series and then find the minimum of them. So for the first power series is an x to the power n, and we have to find limit superior of an whole to the power 1 over n, right? Now notice here there are two limit points in this sequence. Two limit points, not two limits. Okay, two limit points for this sequence. Well, when the suffix is some even number, we get 1 plus minus 1 whole to the power 2n 2 to the power 2n, and minus 1 whole to the power some even number is 1, so 1 plus 1 is 2, and here in the denominator 2 to the power 2n, so it will become 1 over 2 to the power 2n minus 1. And a, when the suffix is some odd number, which is 2n plus 1, we will write it as 1 plus minus 1 whole to the power 2n plus 1 over 2 to the power 2n plus 1. And we know that minus 1 whole to the power some odd number, odd integer, is 0 over 2 to the power n plus 2n plus 1, which is 0. Okay, so we have to find the limit for this subsequence whole to the power 1 over 2n. Why? Because see, here the power is 1 over n when the suffix of a is n. So if we want to find the limit superior of mod an whole to the power 1 by n, then it will be equal to limit of the subsequence a2n mod whole to the power 1 over 2n. See, the suffix here and the denominator of the power both are same. So it will become limit of n tends to infinity 1 over 2 to the power 2n minus 1 whole to the power, this is positive, so we omit the mod sign. Okay, 1 over 2n. So it will become what? Limit n tends to infinity 1 over 2 to the power 2n minus 1 over 2n, which is equal to limit n tends to infinity 1 over 2 to the power 1 minus 1 over 2n. Now as n tends to infinity, this goes to what? 1 over 2. So the radius of convergence for the series an x to the power n is what? R1 is equal to 1 over 2, which is 2. Similarly, we can find the radius of convergence for the series bn x to the power n as 1 over 3, which is 3, which is equal to R2. Now to find the radius of convergence for this series, for this power series, we have to find the minimum. That means R is equal to minimum of R1 and R2, and minimum of 2 and 3 is 2, so the radius of convergence is 2.